Hey math kids, today we're going to talk about combinations and permutations, but before we do that, we need to talk about factorials. So factorials look like this. So if we have 2 factorial, what that means is 2 times 1. If we have 6 factorial, it means 6 times 5 times 4 times 3 times 2 times 1. So if we open up a calculator and we just go 6 times 5, 4, 3, 2, 1. 6 factorial is equal to 720. Okay, now that we know what a factorial is, now we can use these formulas for combinations and permutations. Now, if we have, there's a device called a combination lock. You've probably used it before for if you've ever had a locker or something like that. Now, if the combination to your lock is 3, 5, 7, if you do that out of order, 5, 3, 7, or 3, 7, 5, or 7, 3, 5, etc., none of these will open your lock. So in other words, order matters. Now, when order matters in math, it's actually a permutation. And combination doesn't matter. So, if we were living in math world, then a combination lock would actually be called a permutation lock. If we had a device that was mathematically a combination lock, then all of these would open your lock. You would just have to have the right 3 numbers. You wouldn't have to have them in the correct order. Okay, now I'm just going to go through a couple problems right now. We'll get more into like real world context and stuff like that in the next video. Right now I just want to show you through these formulas. So for example, if I'm given 5C3, that means I'm using this formula. And so the first number is our n, and so that translates into 5 factorial, and then r is the second number, so that's 3 factorial, and then n minus r factorial. So this part is really a 2 factorial, and you don't want to multiply these together. You don't want to say 3 times 2 and make it 6 factorial, because that doesn't actually work. I'm just going to write out the top, so it's 5, 4, 3, 2, 1, all multiplied together. And then the bottom is 3, 2, 1, and then a 2, so it's 2, 1. What I'm going to do is I'm going to cross out anything they have in common on the top and the bottom. And then 5 times 4 is 20, 2 times 1 is 2, and if I divide those, overall, this just equals 10. So 5C3 is equal to 10. Okay, now let's try 7C4. So the first one goes on top, 7 factorial, 4 factorial, 7 minus 4 factorial. Once again, I just use this formula. The first number is n, the second number is r, and I replace those values. This becomes 3 factorial. On top, I go 7, 6, 5, 4, 3, 2, 1. The 4 factorial gives me 4, 3, 2, 1. And the 3 factorial gives me 3, 2, 1. So I cross out 4 on top and bottom, 3 on top and bottom, 2, 1. Okay. Now, if I multiply 3 times 2 times 1, that becomes a 6. So I can also cancel the 6's. Now I have 7 times 5 is 35. Now, if this cancellation is kind of confusing you, feel free to just type everything on the top into a calculator, write it down, type everything into the bottom into a calculator, write it down, and then just divide it using the calculator. That's okay. Okay, now we're going to move on to a permutation. And I'm actually just going to do these 2 problems again, but I'm going to use a p instead. So I'm going to do 5p3. And so I plug that in, so I get 5 factorial over, notice how the only difference is there's no r factorial on the bottom. And then I get 5 minus 3 factorial. So I'm going to end up with 5, 4, 3, 2, 1. And then those become a 2 factorial, so 2 times 1. Okay, so now we have 5 times 4, which is 20, times 3, which is 60. So notice, when we used a combination with those same numbers, we got a 10, and when we used a permutation, we ended up with 60. That's because order does matter, and so there's going to be more possibilities with that. Okay, and we'll just do the last one. So it's going to be 7p4. So I'm using this formula up here. 7 factorial over 7 minus 4 factorial. So we get 7, 6, 5, 4, 3, 2, 1. And then this is like 3 factorial, so 3, 2, 1. Cross out the 3, 2, 1. And I'm going to pull up calculator for this one. So 7 times 6 times 5 times 4, and that gives me 840. So once again, we see over here we only got 35 when we were using a C with 7 and 4, but the P is substantially larger. If you need additional help, please come to Math Lab. Until then, calculator.